In this video tutorial, circuit analysis using MATLAB is explained. Two analysis methods will be presented, namely loop and nodal analysis. In loop analysis, we want to find the loop currents for a DC circuit. Now consider the circuit shown in this example. The loop currents are designated, and KVL is applied to each loop to get the matrix equation. Once we have this equation, now we can use MATLAB to compute the loop currents. Once we have the matrix equation, we can now use MATLAB to find the loop currents. First, we need to create a script file to contain our code. The first thing we need to declare is the vector v. Next, we need to declare our matrix R. Taking the inverse of R and multiplying it by v gives us the vector I. Now we use a display function to display the vector I. Now we run the code and observe the output on the command window. And you can see on the command window we have the loop currents. I1 is 1.25 ampere and I2 is 0.5 ampere. In nodal analysis, we want to find the nodal voltages as shown in this circuit. We then apply KCL to each node and determine this matrix equation. Using MATLAB, we then solve this matrix equation and find the nodal voltages. In MATLAB, we write this code to find and display the nodal voltages. First, we declare the vector I. Then we declare the matrix Y, which is the admittance. And then we calculate the vector v by taking the inverse of y and multiplying it by I. And then we use the display function to display the vector v. When we execute the program, the nodal voltages are displayed on the command window, where we see that V1 is 14.97 volts and V2 is minus 3.2 volts. This concludes this video tutorial.